Okay, welcome, Tuesday, October 13th. And this is week 7. We're going to do some very specific tasks today, practicing factoring. And you are getting ready for your exam, number 1, which is next week. So if you have any questions you want to ask about that, you can prepare to ask those. I'll give you some more information if I have it. Let me just say I got everything I want. Yes, I think I do. Just want to see if I have some papers here. Got that. Okay. And I've got this paper being recorded. Sometimes I forget at the very beginning to turn on this paper to be recorded. Okay, so this is the plan today, and I'll take you past our website. Let's get rid of that. And I'm just going to flash the homework in front of you that you're getting ready for tomorrow night. But our subject today is factoring. And last week, when I was unavailable for a class, I was at a conference, I let you do the factoring problems in the XYZ homework, just greatest common factor and grouping. And I'll remind you of what those are now. But the meat of factoring is factoring out trinomials and special products. And even for me to use the word factoring, I'm going to have to say something about exactly what that means. Factoring is a code word. Factoring is just a very special code word in algebra class and in mathematics in general. So I'll remind you what that is. We this week are going to look at several sections. And they all kind of go together. These first 3 sections, 5, 6, and 7, go together. That's how we'll treat them today. And then on Thursday, we'll look at 8 and section 6.1. So what kind of information do you need about the exam? I think we're getting ready for you to hand in these sections next week. You want to know what the sections might be that show up on the exam. We're going to go up to section 5.8. So not every single thing we do this week, but getting to, I'll come back to that page in a second, getting to the end of chapter 5. So everything we've done up through the end of chapter 5 in our class. Maybe we haven't done every single section in the book, so just the sections we've done, sections on our schedule. And then the next test will pick up at section 6.1. But I thought it was more reasonable to just make a clean break at the end of the chapter. Other simple question, and you can insert your own here, but other simple questions, about how many questions are on the exam. I can be more specific on Thursday because I haven't finished writing it, but I'm thinking about 5, 6 questions, and then maybe, as I said to you, a question with multiple parts, like a question with 4 parts is 4 questions. That's the way I do it. So I don't want to say, oh, there's only 3 questions on the test, but then every question had 8 parts. And that's 24 questions. Now I'm thinking about 5 or 6 questions and maybe counting all the parts, in the neighborhood of 9 to 10 parts. So, it's definitely not extremely large, but I haven't really settled on exactly how many questions there are. And that means that I can't ask you a question about every section. Well, that would certainly have gone way past 6 or even 10 questions. So I'm going to be selective, and you have to prepare all the sections that we've done. I'll go back to my website here to show you where we're going to deliver this. I will post the exam by Wednesday, October 21 at 11:59. So you're working on some homeworks that you're going to submit this Wednesday, October 14, and next Wednesday, October 21. So when you submit those homeworks that go up through section 6.1, when you submit those homeworks on Wednesday the 21st, then I'll release the test by midnight, and the test you have 48 hours to look at and submit by 11:59 on Friday, October 23. So 48 hours to look at it, sure, but you're not going to do 48 hours of math. I understand that. You have other schedules you have to manage, so that's why it's not a very long test. If we look at week 8, remember, in week 8, I haven't filled in everything in week 8 on my site, but I'm not going to present any new material in week 8. The week here is really dedicated to you taking the test from late Wednesday night to late Friday night, your 48 hours. So on Tuesday, we can have review of any problems you'd like to do. And on Thursday, you can come to class. I can't answer questions about the test questions that you'll be looking at on Thursday, but I'll put it like this. On Thursday, any question you ask me about a recommended problem is legitimate, because I wanted you to do the recommended problems for practice, and if they're good practice for the tests, then any recommended problem you ask me about, I can't deny you. But I want to say this, and it sounds extremely harsh, but I do not need to review, and I'm not going to take the test. I have another issue. I'm going to have to grade the test and write the test, but I'm not going to prepare a review for you because I'm not reviewing for the test. So you bring on Tuesday the problems that you want to do. If you have nothing to bring on Tuesday, then I'll do no problems with you. If you have nothing to bring on Thursday, then I'll do no problems with you. But I won't make up problems for me to do in front of you. I don't want that to sound harsh. I want it to sound like you tell me what you need. I don't tell you what you need. So you get together as you're practicing, as I know several of you have been practicing and sending me questions. You get together as you're practicing a list of the problems that you have an issue with. And it could be from the homeworks that you've submitted on XYZ homework, as some of you have sent me questions. But you send me a list or bring a list to these meetings next week on Tuesday and Thursday. And then we'll do those. But I won't make a list of things that I want to do because I'm comfortable with the problems as they are. It sounds silly, but it's your party. So you bring the list of things you want to review. Also notice in next week, you will submit the homework on the 21st. But then since we're not covering any material in the next week, I didn't give you another homework for the 28th. I figure, okay, you submit homework on 21st, you submit exam on 23rd. I'll give you the weekend off because you've done your job. So we won't cover any new material next week. It's all review for you. And then the next homework will pick up in the following week. So after you do your submission of homework 6 and the XYZ sections up to 6.1, then we'll give you the exam. You hand in the exam 48 hours later. And then you can, relax a little bit on the weekend. Okay. I don't know. I mean, that's just two things that came to my mind. Do you have any questions you want to ask about the exam before we get into ordinary business?
So, just to be clear, so on Thursday, it's just going to be another review day. Do we actually need to show up for class that day?
That's a great question. I'm just writing down what I wrote there. And I'll come back to this website in a second. Yeah, I'm definitely calling Tuesday a review day. And in Thursday, you'll be doing the test. So I'm going to say Thursday, you're not going to be reviewing so much as you're going to be working on the test and digging up any similar problems from the recommendeds you want to see or something like that. So let's call Thursday a working day. But I want to say something else just related to your question. You know, I know some of you consume this on the recordings because you might be occupied at the time we're meeting live. I have a great deal of respect for you guys coming and showing up and doing the work anytime. And the great majority of you are showing up and doing the work every day. So I don't ever want to make it feel like you got an obligation that you must be here. Now, I have legal responsibilities and the college has financial responsibilities. And so therefore the college actually requires instructors to take attendance. And in an ordinary classroom, I would be checking attendance by the assignments you submit. Here, because I know everybody's schedule is just weird, I do not make a list of whether you're here on one day or another day. I do not keep attendance in that sense. I keep attendance strictly by, did you complete this week's assignment? Did you submit it? Not did you get a grade of A or B or 8 or 9 or 2 or 4 or 6. I just say that the attendance that I'm marking, that I'm required to mark, is simply you have submitted your assignments on time. So I respect that you guys are showing up here at all, but some of you are consuming it in recordings, and I respect that too. Don't feel obligated if you have something else come up that you have to be present at this time. So it's a long way of saying, no requirements attending on Thursday or any other day. You're just making sure you check in and do your work. No, you do not have to come on Thursday if you're just tearing into that exam and you're satisfied. I won't be presenting any new material. I will record the class sessions in case you are ordinarily not available at this time and people are asking good questions. So I'll record the class session as normal. Trevor asks, will the exam be printed? And the answer is yes. I will print it just like I print your homework problems for you. And that is, some of you write the homework problems and then do them. Some of you have access to a printer, some of you don't. I think your life would be a little bit easier because let's say there are 6 problems. Let's say there are 10 parts total, and I'm just throwing those numbers out there. You could imagine that this test, if I give you room to work, could have 6 pages to it or something like that. So I will just, like the homework problems, which I usually just put up as 1 page, I will post the exam as 6 pages together in one document. You could print that. You could copy it by hand if you wanted to. I don't know if you got some friends or some access to something that's open right now, libraries or such. You can actually come to Delta College and print things if you wanted to, but I don't know how close you are to Delta College. Print it out if you can, just to save yourself trouble writing, just to save yourself time writing. but it'll appear just like a homework problem, except it'll have 5 or 6 pages to it. Okay, so that was Trevor's question. Thank you. That's a good question. Is there any other question you'd like to ask before we get into it? Okay. If you other questions will come to your mind, and you can either toss them out here or you can bring them Thursday. That's fine. You can bring them next Tuesday. That's fine.
I actually do have a question.
Go ahead.
Do we submit the test like in the format of the homework's just instead of homework, number, it'd be test, whatever?
Yeah, you could do it like that. That's a good question too. You could say your name, not mine. Exam 01 math 119. I know some of you think, and it's perfectly okay. You say, "Oh, this naming thing you do is a mess." I just forgot whether I put a W there or not. I'll tell you, that looks ridiculously long, doesn't it? And someday maybe I can show you my system behind the scenes, but I'm not going to show anybody's individual papers or work. But as much as I can, I think lots of instructors are doing this as much as they can, try to automate things in the background. So if I'm getting 14 or 15 papers from one class and 20 from another class and 22 from another class, the problem is I'm collecting all these files and every week, and if everybody got a different name on them, everybody got a different way of writing them, things would get lost, things would get missed. I very much appreciate that you guys are working on naming this. I mean, you guys are, what is a compliance rate? I mean, you guys are above 90% compliance for sure. And if you ever give me one that's got, the name not on it, I'll just send you a reminder. Please put it in that form. I don't detract points from you. But I'm just saying, when you name it in that ordinary way, it helps me a lot. So I appreciate that. So just substitute exam 01 for homework 04 or whatever. So that's a great question. Okay, very good. If other questions come to you, you can just spit them out or throw them in the chat, even if we're talking about something else, and you can bring them Thursday too. Okay, so what are we working on right now? Here's this word, and you probably have heard it in lots of classes, math classes. Maybe you've heard it in every math class you've ever taken. Maybe you're sick of it. That's, in some sense, that's the danger, is when you become too familiar with something, you think you're familiar with it, you think you got it, and you may not have totally got it. Or, just let someone else in here, maybe you're pretty good at factoring. Maybe you're like 85%. Maybe you're like 92%. And you recognize a lot of the things I'm going to say today. But if I could show you one thing, even one thing that made you faster, it might be worth your while. If I could show you any one thing that might reduce an error, it's worth your while. So if you consider this reviewing because you've done it before, that's fine. If it's totally new to you, that's fine. That's the way I'll treat it. But always be careful when you think you know something. Always be careful when you think you got something. You may have got it, but if I can just eliminate that one chance in 10 that something could go wrong, it's worthwhile. So factoring is basically, in plain English, breaking something into smaller pieces by multiplication. So factoring, in a sense, is another form of dividing. And, it kind of goes like this. If I ask you what 6 is made out of, you say 2 times 3, and you are factoring. And this thing right here, the 2 and the 3, these are called factors. And this thing, the 6, is called a product. Now, I didn't ask you to break up 6 by saying 1 plus 5 or 2 plus 4. Breaking something up by addition is a different word. And it's also an important word in mathematics, but not important to us right now. So if someone, I hesitate to write this just in case you don't do it, but if someone says 6 is 2 plus 4, you are absolutely right. And when you break up something by addition right here, you call these a sum, and you call these things summands. And when you break something up by addition, it's not called factoring, it's called partitioning. And that would be a great thing to learn someday in another math class, because there's a whole different idea about partitioning. And you say, my gosh, that looks simpler than factoring. Why would I ever want to do that? Actually, it's really important, but it's just not on our table right now. So factoring. And so if I say 12, you say 2 times 6. And your friend says 3 times 4. And you both factored. You broke it down into smaller pieces by multiplication. But we're going to go one step further. And I'm just using numbers to illustrate the words right now. We're going to demand that you factor completely. So that's usually the problem. Give people a pain. What does it mean to factor completely? I factored, but he told me I didn't factor completely. Well, the idea is not just to break things into smaller pieces, but to break things into the smallest pieces possible. And it wouldn't take you long to think about this. You could say, I could improve both of these. I could think of 6, as I already did, as 2 times 3. So 12 is actually 2 times 2 times 3. And you cannot do better. I mean, I'm not going to let fractions come in here. I'm not going to say 2 is 4 times 1/2. We're not talking about fractions. We're just talking about whole numbers. 2 times 2 times 3 is the tiniest pieces I can have. When I look at 3 times 4, your friend said 3 times 4, quickly you and your friend realize, oh yeah, 4 is 2 times 2. And then I want you to look at that. So when you and your friend are done, even if they started in a different way, you will have the same pieces. So how do you know when you factor completely? Because you will have pieces that cannot be broken down anymore by multiplication, and you will have the same pieces. Now, people can get really crazy, like factoring 12 is not such a big deal. But if I ask you to factor 248, then it would take you a second or two. There's lots of things you can do. It's say 4 times 62, that's 248. 4 is 2 times 2. 62 is 2 times 31. Took me a few more seconds, but now I'm done. 248 is 2 cubed times 31. 2 cannot be made any smaller, and neither can 31. numbers that cannot be broken down into smaller pieces, you might have heard this word before. They're called prime numbers. Prime just means cannot be broken down again by multiplying. You can only make 31 by saying 1 times 31. You can't say 5 times 6. Can't use fractions. We're not using any fractions. I could say 5 times 6.2 is 31, but that's with fractions, decimals. Okay, now let's expand it to where we've been recently. And that is, you can factor numbers all day long. And this is a basic truth. The bigger the number, the longer it takes you to factor it. So if I was really brave, I'd pull out a 5 or 6 digit number here, and you and I would try to factor it, but it wouldn't be easy. As you add digits to the number, it makes the factoring harder and harder. And math people generally say exponentially harder. So even factoring numbers is not like an easy or sure thing. If I told you 216,421 and told you to break that down into tiny, tiny pieces, by hand, you and I might take some time at that. Might take quite some time at that. But a computer could do it just about instantly. So just for kicks, let me run this into a computer program. Then I have sitting here, let's say factor 2016, 216,421. And let's see what the calculator says. I gotta make sure I'm using this command correctly. No, so I got to make sure. I'm using a special program, but some calculators will do this for you too. I'm using a special program called Mathematica. You know, that's even better. I should not have done that. Let me do this. Have ever, tell me, shout if you heard this before. And I'll show it to you in my browser. Has anybody heard of Wolfram Alpha? Has anybody heard of this website? It's kind of like a Google for math. And you can ask it questions in plain English. Factor the integer 6. And it'll come back to you and say, okay, factor 6, you must mean 2 times 3. And it'll give you other questions. This is a little bit like Google for math. So I think if I want to make my life easy, I could just type it in here. 216,421. Factor that one for me, Mr. Big Shot computer program. Oh my gosh, look at that. 2016, 421. It is a prime number. It cannot be factored. Now, I want you to think about that for a second. The computer returned that answer to us in about a second or two. You and I, had we kept trying to factor it for the rest of the day, would have still not been sure that we had covered every possibility. Let's change that 1 to an 8. Okay, 216,428 happens to be 2 times 2 times 61 times 887. Again, you and I could not do that if I gave you maybe an hour and a calculator and a supply of Cheetos. It would take you a while. But if you have never seen this before, Look at Wolfram Alpha. It's kind of like Google for math. It's kind of interesting. Okay, let me go to the paper. This is actually a prime number. So who cares whether a number can be broken down or not? Actually, you care deeply, although you don't see it in your everyday life necessarily. And this is related to all kinds of things with computers, security, credit cards. The fancy word, and maybe you've heard it before, is cryptography. Cryptography is, in English, writing in codes, coding, securing information in a code. And there's a lot of ways you can secure information in codes based on prime numbers, except not based on prime numbers with 6 digits, but based on prime numbers with hundreds or maybe thousands of digits. I want you to look at it this way. You and I would have a hard time deciding whether that number is prime. And the computer had no trouble. But you could use your imagination. If you kept making the number bigger and bigger, would you reach a place where the computer had trouble? Yes, you would. But it would be, again, possibly thousands of digits. And so if you were trying to hide some information or secure some information encoded, credit card, numbers, things like that, what you can do is use prime numbers in a special way to scramble the information. And if the computer could unscramble it in 100 years, what do you care? Sure, the computer will unscramble it in 100 years, but by then you've already purchased that shirt from Amazon.com. Nobody picked up your credit card number in the transaction. So I mean, there's a reason why people like to factor numbers, because it has a lot to do with computer security in general. Okay, then let's move on. Although factoring numbers by itself would be enjoyable, we're interested in factoring these things called polynomials. Here's a very simple polynomial. 2 terms, degree 1, a binomial, if you will. But you can ask the same questions about this as you asked about 6. How can you break down 6? 2 times 3. But this can be broken down as 2 times x. And you say, oh, they both have a 2 inside them. So even if you wouldn't have thought of this before today, let's think about it like that. 2x plus 6 is 2 times x plus 3. That is factoring. There's a factor. There's a factor. And there's a product. So if factoring numbers was cool and had some application to security, I'll tell you that factoring polynomials has an even larger application to cryptography and security. So factoring polynomials is a very, very big deal. The ones that you and I do every day in the algebra class, they're not as nasty as the ones that are, like 20, 30, 40 pieces long. This is only 2 terms. That's not a bad thing to factor. Maybe we'll factor things with 3, 4, 5 terms. But if you get into things that are much, much larger, just like numbers that are much, much larger, it can be very hard for humans to factor it, even very hard for computers to factor it. And that's when you can make some really secure codes. Okay, let me try again. So on this piece of paper, I have the famous 4-step factoring process. And, people argue about this. Actually, your book has 5 steps, and I like your book's 5 steps. But depending on which book you pick up, they say 4 steps, 5 steps, whatever. But these 4 steps are definitely major steps that everybody uses when they factor. And they use them in this order, and you should use them in this order. So last week you practiced possibly some problems. You might not have got to it in XYZ homework about factoring out the greatest common factor. That's what I just did right here. I have 2 terms. They both have a 2 in common, and there's nothing else they have in common. So if someone asked me, what is the greatest common factor between those 2 terms, I would say 2. And then they would tell me, why don't you factor out the greatest common factor? Most people just say GCF, greatest common factor. And that's what we did. Now, when you do this, there's some rules. Every game's got rules, right? So I'm going to say, look at these 2 pieces, 4xy, 24y. You have 2 pieces like the one above. You definitely have things in common. It's clear that they both have a factor of y. It's clear that they both have a 2. So there'd be nothing wrong with me writing 2 times, and then tell me what's left over. If I remove a 2 from 4xy, I pull it outside, it's like dividing by 2. I'd have 2 times xy left. 2 times 2xy is 4xy. Pull a 2 out of here, divide this by 2. I have 12y. Now this is true, but it's not complete. Likewise, I could pull out a y and be left with 4x plus 24. Again, true, but not complete. I could pull out a 2y. Now I'm getting silly. That leaves 2x plus 12. True, but not complete. When someone says pull out the greatest common factor, they want it all. They want everything that these people have in common. Actually, these 2 people have a 4 in common and a y in common. They have 2 2's, a 4, 2 times 2. And if you remove it, that leaves behind x plus 6. You realize in each of these cases, you could have seen the x plus 6 and the 2. Here you look at this and say, wait a minute, I could take out another 2. Here, you look at the 4x plus 24 and you say, wait a minute, I could take out a 4. Even right here, you say, oh, wait a minute, these 2 people both have a 2 and a y. But you notice when you're done, each time you said, pull out another pen color so you can focus on this. Each time you said 4y times x plus 6. 4 times y times x plus 6. 4 times y times x plus 6. Or if you'd just done it all in the first step, 4 times y times x plus 6. So that's called removing or factoring out the greatest common factor. Now you say, well, I remember doing that before. I've done that before. That's the easiest thing. Get to the more interesting things. Actually, pulling out the greatest common factor is like the #1 mistake people make. They look at something that's too complicated and they say, I can't factor that. It's too complicated. And I say, did you pull out the greatest common factor? And so, oh, I forgot that. After you pull out the greatest common factor, do you see what happens? the thing naturally gets easier to look at, naturally gets smaller. Okay, so greatest common factor is always step one. Don't begin until you removed everything that everyone has in common. Even if I got 3 pieces here, like x cubed minus 2x squared plus 6x. Now I've got 3 pieces, and they really don't have a lot in common, but they do all have 1x. I wish they had more. They certainly don't have any numbers in common. There's no number here. Could I pull out an x squared? These 2 people have 2 x's factored, but this person does not have 2 factors of x. So the best I can do is pull out that 1x, and I'll be left with x squared minus 2x plus 6. And if that's all I can do, that's all I can do. In this case, it turns out to be the fact that that's all you can do. That is the greatest common factor, and that cannot be factored. But that's another bullet. How do I know that can't be factored? In fact, that's step 5 in the book's rules. The book, the author, and I like this, actually adds a 5th step. Are you sure you're done? Are you sure you cannot factor further? Never stop until you're sure you cannot factor anymore. Okay, let's move on to a different factoring. So step number 1, greatest common factor. Factor it out. Step number 2, factor by grouping. And this is also, in a way, looking for common factors. Let me show you. So if I had something like 2x times x plus 2 minus 3 times x plus 2. Now just hang on to this for a second, because I'm showing you this because I'm preparing you for the next one I'm going to write. Now here you have 2 giant terms. Do they have any numbers in common? No. Do they have a variable like x or y in common? No. But they do have something in common. They have this chunk, this factor of x plus 2 in common. How do I remove it? How do I factor it out? Same way I factored out numbers. I pull this out to the side and tell you what's left. What is left if I remove this x plus 2? If I divide by x plus 2, what's left in the first piece is 2x. What's left in the second piece is minus 3. So I just factored this completely into 2x minus 3 times x plus 2. Now you might be tempted to say, but that's too obvious. I knew there was an x plus 2 there. I would have had no problem doing that. I've already done those. Okay, now let me do it this way. 2x squared plus 4x minus 3x minus 6. Now I want you to factor that. So the command today is factor. Factor, 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 factor. That's all we're going to do. And I'm just trying to show you how to be faster at it. Now let's factor this thing that I just wrote in blue. 2x squared plus 4x minus 3x minus 6. You know the rules. You guys are good at rules. You say, okay, he told me to look for common factors. Are there any common things among these 4 pieces? And though the answer is there are some common things among some of them, like, oh, the first 3 got an x. Oh, the last 2 both have a 3. The first one and the last one have a 3. The first and second have a 2. The second and the fourth have a 2. So there's no common factor among all 4 pieces. That's the first thing you look for. And the answer here is no. But if you can't have what you want, don't you settle for what you could get? Remember the Rolling Stones? I hope you guys know the Rolling Stones. What was one of their number 1 hits? You can't always get what you want. But if you try sometimes, you just might find you get what you need. Okay. The Rolling Stones were actually excellent mathematicians. All 4 pieces don't have anything in common, but look at this. First 2 pieces do. Even the second 2 pieces have a 3 in common. I can go farther, but look at the first 2 pieces. If I see the first 2 pieces, they both have a 2, they both have an x. That's the most I can get. If I pull out that 2x, do you see what's left over? 2x squared, and I remove a 2 and an x. What's left is an x. Here, if I have 4x and I remove a 2 and an x, I have a 2 left over. Now, in the second piece, let's be careful with these minus signs because signs belong to numbers. When I say 2x squared is 2x times x, what I'm really saying is positive 2x squared is equal to positive 2x times positive x. You know, plus 4x. I didn't want to write a minus 2 in here. 2x times minus 2 would not be plus 4x. So don't disrespect signs. Say, I look at these and they have a 3 in common, to be sure. But if you just say they have a 3 in common and go on, I'm going to challenge you. I'm going to say, is that a plus 3 or is that a minus 3? You have to be specific. You want to remove the minus 3 from these 2 people. Why? Because after you remove the minus 3, what's left here? Positive x. What's left here after you remove minus 3? After you divide by minus 3? Plus 2. And then you realize, oh my goodness, that was the problem we just did above. And remember the book's 5th rule. Are you sure you're done? Never stop until you're sure you've done everything you can. And then you say to yourself, that's fantastic. I've got another common factor. Here's the final answer. That's factored as much as I could. I'm just thinking about math and rock and roll and things like that. Did you know that, I can't remember, I think it was the guitarist for Queen actually was had his doctorate in physics, had a PhD in physics, I think. And that song, We Will Rock You, you know, we will rock you, pum, pum, ch, pum, pum, ch. They recorded that. You can go look this up. They recorded that by taking the sound of one hand clap and then mixing that sound. And they wanted it to sound like a crowd of people clapping their hands in unison, right? So what they did, I believe, I read this now. Am I reading the story? Am I reading the truth? You go find out. Is he took the hand clap and he kept remixing it at like random intervals using the digits of pi. And, you know, very, very close together so that it sounded like a large group of people stomping their feet and clapping very close together, but not quite perfectly together. Because it was just one loud clap. Well, nobody claps like that, right? Okay, so you would be surprised the silly ways people use math in crazy unexpected places. Okay, got it. So this is called, when you do this, when you group things two at a time, that's called factoring by grouping. And technically, that was in the section that I asked you to do last week when I wasn't here. So greatest common factor, let me get my paper here. Greatest common factor in factoring by grouping, they were in section, let's just get it straight. They were in section 5.4. So you were practicing that kind of by yourselves. Now, maybe what I said here makes it a little bit better for you, but you can keep doing those problems. Those are the ones that are going to be submitted in your XYZ homework for Wednesday. Those are among them. So just be sensitive that maybe if you don't have every piece share something, you might be lucky enough that you have something shared among several pieces. Now, just as a sample, look at section 5.4. I'll pick out problem number 30 in the text book. And let me write this down, then we'll take a little break. Say I got x cubed, y cubed, plus 2x cubed, plus 5x squared, y squared, plus 10x squared. Always make sure you copy these right. Sometimes you're spending 5, 10, 15 minutes on a problem and you cannot do it at all. And then you look back at the book and you realize you copied it wrong. I do that all the time. Just copy slowly and carefully. Okay, what am I going to do? I'm going to go through my checklist. Any common factors? By numbers, no. 2, 5, 10, 2 and 10 have a common number, 5 and 10 have a common number, but there's no number that's common to all four pieces. But everybody's got x's. These first two pieces have 2 x's or 3 x's in common. Here's 2 x's. What's the most I can remove? Everybody's got 2 factors of x squared. What does that leave behind? Xy cubed plus 2x plus 5y squared plus 10. When I say what does it leave behind, x squared times 10 is 10x squared. X squared times 5y squared is 5x squared y squared. X squared times 2x is 2x cubed. X squared times xy cubed is x cubed y cubed. What's left after I pull it out? What's left after I remove it? What's left after I divide it? Is that the best I can do? Well, no, I say I might have pulled out the most that all four had in common, but how about looking at these first two or last two? They certainly have something in common, so do these two. Now don't throw out this x squared. In fact, don't forget about it at all. Let's just write it outside. But let's talk about the 5y squared plus 10. If I take out a positive 5, I would be left with y squared plus 2. In this problem, did I miscopy it? Something tells me I miscopied the problem. And the reason I know I miscopied the problem is because I have like this very bad eyesight. But if I look at it with one eye differently, then I have a 3 here. It's not a great deal of damage. Don't panic when you find something like that. Just see if you can fix things. That would leave a 3 there. And that would leave a 3 here. Okay, now I feel better. This is the same problem in the book now. Okay, so how about these two pieces right here? Do you see they both have an x in common? And then they have y cubed plus 2 left over. And there's a signal that I'm doing something right. I see another common factor. Now, don't forget about the x plus 2, or else you get the answer wrong. But let's leave it out there. Let's remove this green stuff, y cubed plus 2. What would happen after I remove y cubed plus 2 here? I'll have an x. What happens if I remove y cubed plus 2 from this person? I have a 5. Now I've broken it down as far as I can so far by grouping. Factoring out the common factor, get the x squared. Factoring out the grouping, get the y cubed plus 2. This is now x squared times x plus 5. I don't need all these parentheses. These extra blue ones I don't really need now that I'm done with the insides. It's y cubed plus 2. I cannot do better than that, even with the things I'm going to show you after the break. So this is factored completely. That's our goal, always completely. Okay. Let's take a short break here. So we got 10:59, let's say 12:59, excuse me. Let's come back in 5 minutes. You go stretch your legs. And I'm going to show you the other two steps in this technique. Factoring is really nice and focused. I mean, you got to do a little work and some more work down here, but it's a very, very focused mission. And I think you can do well at it. So I'm going to mute my microphone while you guys take a break, stretch your legs. Okay, back to work. And on to the next step, which is what do you do if you don't make any progress with these two? What do you do if you want to keep trying, but you've already done remove the greatest common factor, factor out the greatest common factor? You've already grouped all you can. Does that mean you can't do anything else? The answer is not necessarily. So let's talk about trinomials. I'm going to keep this paper in front of me, this example in front of me, because that's how we're going to make progress. Just for fun, if you guys went and looked up Brian May, I thought it was a guitarist, Brian May. English musician, singer, songwriter, record producer, rock band Queen. He has a PhD in astrophysics. So, okay, it's not quite math, but I mean, physics and math are close. So, if you haven't listened to that before, give it a shot. Okay. What could you do if you think you've done it all as far as removing common factors? And I'm going to come back and point to this problem in a second. But let's try something else out. So this is called factoring trinomials. This is the part where people are usually not super sure of themselves. Like they always say, how did you see that? Or I didn't see that. How did you see that? Let's try it out. If I write x squared minus 2x plus 3x minus 6. And think about grouping. Is not large numbers. So you could say, oh, I see a common factor of x minus 2. These two people have a common factor of 3. Now you should pull out a plus 3 or minus 3. So that you could ask yourself, maybe I should pull out a minus 3. But that wouldn't do because then you'd have a negative x left behind and a positive 2. Now, you might have been true, but these don't match. X minus 2 and minus x minus 2 don't match exactly. So you'd be better off removing, sorry, I'm getting sloppy, removing the plus 3. Then you have x minus 2 left over. And you can finish by saying x minus 2, pull it out. I'm left with x plus 3. So when I factor this, I get this. But what if I had written x squared minus 2x plus 3x minus 6 in a different way? What if I had tried to hide this from you? Because these two middle terms actually are common terms, right? I can add them. Minus 2x plus 3x is 1x, positive 1x. So here, I've got this positive 1x. This is trinomial. But since it doesn't look like this, and I'm not handing this to you on a silver plate, you're not sure whether you can factor this or not. Let's go through our checklist. Remove the greatest common factor. Three pieces, they have nothing in common. Group. Well, I group the first two and take out an x, but that doesn't really help me too much. No, only if I think about this in this way, maybe, would I make some progress? But is there any way I could shortcut this so that I don't have to actually go backwards and create 4 pieces instead of 3? I mean, I don't want to create extra pieces if I don't need to. So is there any way I can see this answer without working backwards to this bigger thing? The answer is yes. Let's think about multiplying these two people. What's the word for multiplying? Distribute, right? X times x, x squared. X times minus 2, minus 2x. X times 3, positive 3 is plus 3x. And 3 times minus 2 is minus 6. Let me write that larger because I want you to see this in a nice diagram. It's very clear that on the outsides, I get x squared, x times x, and minus 6, 3 times 2. What I do not see that shows up in the original problem over here is the inside terms. Did I just FOIL first and last? But what about the outside terms, minus 2x, and the inside terms, positive 3x? And then I realized, oh, they're common terms, plus 3x minus 2x. I should put them together. When I do put them together, I get the plus x. And that's what I looked at a second ago. So instead of multiplying, factoring is just multiplying backwards. I want to go from this 3-piece polynomial to this 2 binomials. Factoring is just multiplying backwards. So I try another one, x squared plus 5x plus 6. And let's see if you can multiply backwards. Well, you can try a few things and see what happens, right? If you want to have an x squared out front, you're going to have to multiply x times x in a way, if you want to make it smaller. If you want to have a plus 6 in the back, now here you have 2 chances. Well, I guess you have a couple, right? You could do 1 times 6, both positive, or 1 times 6, both negative. You could do 2 times 3, both positive, or 2 times 3, both negative. Now here's a trick question. Which one of these 4 choices is going to get you 5? If you're not careful, you say, well, all 4 of them are going to give me a 5. When I put the outside and the inside terms together, 6 and 1 differ by 5. Minus 6 and minus 1 could differ by 5. 2 and 3 add up to 5. Even minus 2 and minus 3 add up to minus 5. Now, but do you see what the problem is? I don't want minus 5. I want positive 5. Well, maybe I should do 6 minus 1. But I don't have 6 and minus 1. I have plus 1 and plus 6. So if I put a 6 here and a 1 here, this would fail. Plus 1x plus 6x. Positive 1, positive 6 would give me positive 7x in the middle, not positive 5x. So then you say to yourself, well, I've only got a few choices. Which 2 numbers add up to positive 5? Then you settle on these. No chance. Plus 1, plus 6 don't work. But plus 2 and plus 3 do work. And you can use this minus minus plus plus pattern to help you. Do you know that if you had a plus 6 here, you cannot have 6 times minus 1? That would equal minus 6. You can't have 2 times minus 3. That would equal minus 6. When you see this plus sign here, it's going to be either 2 positives or 2 negatives. And then I want to have the middle pieces add up to 5. So try saying it like this. And I'm picking out a mellow one just to get you started. Try saying like this. I want 2 numbers that multiply 2 plus 6 and add 2 plus 5. And the moment you say that, you have the answer. The 2 numbers are 2 and negative 3. No, that's ridiculous. 2 and negative 3 do not multiply to plus 6, and they do not add to plus 5. What about minus 2 and minus 3? Because minus 2 times minus 3 is plus 6. Well, you're right, but they don't add to plus 5. They add to minus 5. The only 2 numbers, the only 2 whole numbers in the universe that are going to do this trick are 2 and 3. They multiply to 6 positive, and they add to 5 positive. The moment you realize that, you've cracked the problem. Let's try it again. That's how I want you to speak and think when you're looking at these. Let's try x squared plus 14x plus 33. Let's try to make it harder. Can you give me 2 numbers that add up to 33, positive 33, by the way, and multiply, that multiply to 33 and add up, I gotta be careful not to be so careless, multiply to 33 and add up to 14, both positive, 33 and 14. What are they? 11 and 3. Yeah, thank you. You guys are faster than I am. And maybe you've also done this before, but this is a great way to think about it. So let's do the safety check. X squared, got it. 33, got it. Plus 11x plus 3x plus 14x. I'm golden. Try it again. X squared minus 7x minus 18. And after you get used to this, you can do it fast. Give me 2 numbers that multiply to minus 18 and add to minus 9. Oh, sorry, minus 7. My fault. The thing that's going to help you here is there's not a lot of ways to make 18, right? I can say 1 times 18, 2 times 9, 3 times 6, and that's it. But you got to get the sign right. Isaiah's got that. They have to be different signs. Now, 3 and 6, they got no chance in the world of ever making a 7, right? I don't care what signs you choose. You will never add 3 and 6, pluses or minuses, and get 7. So it's gone. 1 and 18, absolutely no chance to make 7. I don't care what signs you use. Now you settle on this 2 and 9. Say, can I make a 7 out of that? Sure I can. Can I make a minus 7? That's what I want. Yeah, let's try 2 times minus 9. 2 times minus 9, give me a 18, negative. 2 plus minus 9, give me a 7, negative. The moment you do that, you have the answer. And that is factoring trinomials partly. Now, here's the trouble, is as long as this begins with a 1 right here, it's very easy to play this game with practice. If this is not a 1, it's harder to play this game. So let me show it to you one more time with this 1 in there. And then I'll show you what happens if you don't got a 1. So you had x squared minus 7x minus 18. And you told me that the magic numbers were 2 and minus 9. So what I did right then is, like, very quickly in my head, or maybe just because we've practiced it before, in a way, what I did is separated the minus 7x into plus 2x and minus 9x. Then I could factor by grouping. Then I could see the x plus 2 and the x minus 9. Now, did I really do this factoring by grouping in my head? No. I just liked the 2 and minus 9, so I tested them, and they worked, and I was happy. And that's all you have to do. But if you were stuck, what your brain is doing in the background is this. Let me test you one more time, and then we'll show you what happens if the number doesn't begin with a 1. But I want you to think about this. It's almost impossible for me to make one of these that you can't do now, if you think like that. So let's say minus 12x plus 36. Can you break that by giving me two numbers that multiply to positive 36, but add to minus 12? They are minus 6, minus 6. And the larger the numbers, the more work it takes. But you can test this pretty quickly. Minus 6 times minus 6, 36. Minus 6 times minus 6 is positive 36. Minus 6 plus minus 6 is minus 12. And then you're done. Now, it never hurts to check. Got my x squared. Got it. Got my plus 36. Got it. Minus 6x, minus 6x, minus 12x. Got it. So now I am very happy. In fact, in this case, I might even say, why don't we make it even neater by saying x minus 6 times itself is x minus 6 squared. But now I want you to go back to this problem. Do you notice how that began with a 2? What if I had 2x squared and I combine these into plus 1x, and then I had the minus 6? The moment you put another number in front of here, you got more work to do. It's not going to be x times x anymore, because that's not going to make a 2x squared. To make that 2, you got to put a 2 down here somewhere. It doesn't matter whether you put it first or second. And there's only one way to make a 2, which is 1 times 2. So that's as good as I can do. But the problem now is it's not just two numbers that multiply to minus 6 and add up to plus 1. Three times minus 2 multiplies to minus 6 and adds to plus 1. But I don't care where you put those two. This won't work. You can't just put in the 3 and the -2 because both times you fail, right? What do you mean I fail? 2x squared, I win. -6, I win. But in this case, what you get is -2x plus 6x. You get 4x in the middle. What about down here? 2x squared, bingo. -6, bingo. But in the middle, you got 3x's minus 4x's, and that's a -x in the middle. You say, oh, but that's what I wanted. I wanted an x. No, you didn't. You wanted a plus x, and you made a minus x. So what did I do wrong? Nothing. By guessing. That is true, that 3 times -2 is -6, and 3 plus -2 is 1. But what I did is I ignored the 2. What I really want is to say, what does that 2 do? These are both wrong. Because they didn't work with this 2. So let me show you a silly, simple way to modify this argument. It's called the AC method. Multiply the first number and the last number, and you get -12, right? Now, instead of asking what 2 numbers multiply to -6, now you've considered the 2. Let's give me 2 numbers that multiply to -12 and add up to +1. Go ahead. 2 numbers that multiply to -12 but add to +1. And 3 and 4 make 3 negative, and you're right. So now we've cracked it. Watch. Change the plus x in the middle to -3x plus 4x. And factor by grouping. X times 2x minus 3, 2 times 2x minus 3. They both have the 2x minus 3 winning. After I factor out the 2x minus 3, I have left an x plus 2. Now I'm a little bit gun shy because I've messed up these two. I better check if this works. 2x squared. Got it. That was never in question. -6 on the backside. Yes. Good. But the key was the middle. I kept screwing up the middle. Let's try the middle now. Plus 4x minus 3x. That's what the middle turns out to be. Oh my goodness, it's plus x. I win. This is the answer.
So back when you got the -x, would it just be simpler to change the sign and then it would be correct?
Good. Maybe it would, but you might have been lucky to change the sign to make it work. Now I do have to give you that if I had changed the sign here, I would get a plus x. You are right, but what if I hadn't have been that lucky? So the question is, did that minus x happen because I was lucky, or did that minus x happen because it had to happen? I think the answer in the end is I got lucky right there, but I won't turn down luck anytime I get it. But this is the method that always works No luck involved. Let me show you again. Let's try another one because I want to show you that if you ever get stuck factoring a trinomial, this method always works. If the trinomial can be factored, there may be trinomials that simply can't be factored. So let's try, I'm going to pick one out of the book. I was trying to pick an interesting one out of the book. Maybe not too nice. Well, let's go for a medium one. And then in a second, we'll go for a harder one. Okay. I know how to make 15. There's not too many ways. 1 times 15, 3 times 5. I know how to make 2. 1 times 2, 2 times 1. But what I need is a combination, give me minus 13 in the middle. So you multiply these two numbers. This is when people call this the AC method, it's because they're thinking like ax squared plus bx plus c. They're just calling these numbers letters. So a times c here is 30. Now do it with the plus signs, plus 2, plus 15, plus 30. So can you give me two numbers that multiply to plus 30, do it with the signs, and add to add minus 13? Oh, well, and Jacob, you're right. In the end, the answer is going to be minus 3 and minus 5. But first, just make sure, I want to make sure everybody on the same page. Do these two numbers first. And then I'll comment on why you said minus 3 and minus 5. Because you're correct. But first, let's pretend you didn't see the minus 3 and minus 5. That's what I wanted. The minus 3 and the minus 10. Thank you, Isaiah. Can you find two numbers that multiply to 30 and add to minus 13? And the answer is minus 3 times minus 10 is 30. And minus 3 plus minus 10 is minus 13. But Jacob was still correct. And I'll come back to that in a second. So now I'm going to take the 2x squared and break up the 13x as minus 3x minus 10x. And here I have a common factor of x that leaves behind 2x minus 3. Here I have a common factor. Now be careful, 5 or minus 5. Think about what you want. You want to see another 2x minus 3 badly so you can match. So you should do what to get 2x minus 3 in there? Pull out a minus 5. But once you've done that and you remove the 2x minus 3, then what do you see is left? Minus 5, x minus 5. And that's the minus 3 and the minus 5 that Jacob said he saw. I'm presuming. So here's what I'll say to you. If you see the minus 3 and minus 5 right away, and you test it to make sure you didn't make a mistake, then that's fine. But if you're looking at a problem and you cannot see those right away, this method always works. Let me try a harder one. Yeah, let's go for the gold right here. 5.5, number 53. This probably this actually looks worse than it is, but it's a good thing to see. First of all, where's the x? And then you say to yourself, well, really, X didn't matter. Could have been A here. And I would have been okay. I would have just said A minus 5, 2A minus 3. So the fact that I'm using a letter other than X doesn't bother you. Sorry, just slide up the paper. Maybe the first thing that bothers people is, wait a minute, you got another letter in there. How am I supposed to do that? Well, what if I had a y squared on the back, xy in the middle? Y squared on the back would just be 5y times 3y. And if it's still added up to the middle, xy, negative 13xy, I guess I didn't check this, minus 10xy, minus 3xy is minus 13xy. If it's still added up correctly on the back end and the middle, I don't mind that there are two variables here. It just means there's an a in the front and a b in the back. But does anyone see the two numbers? That's not what's really bothering you. What's really bothering you is, oh my goodness, there's so many ways I can make 18. 1 times 18, 2 times 9, 3 times 6. How many ways can I make 28? 1 times 28, 2 times 14, 4 times 7. Too many choices. So maybe this is hard to see. But this AC method always works. Let's try it out. What's the A times C? Now, I don't enjoy this, but I can multiply these two even with a calculator. 18 times minus 28. What is that? I can pull out my calculator. You can pull out yours. I got, no, not negative 10. I must have typed it in wrong. 18, 28 times. I got negative 504. It was a very old calculator. Now watch this, because at first it looks impossible. I went too far to the right side. Sorry. Can you give me two numbers that multiply to negative 504 and differ, or add up to positive 3? Forget about the A's and B's. You know what? I'm going to put an A in the front and I'm going to put B's in the back. What I need is these numbers that go in front of them. That give me an A squared. Those two give me a B squared. In the middle, I got AB and AB. I need the numbers. Now this might take some hunting. But think about it. Two numbers that multiply by minus 504. You know, one of them's got to be positive and one of them's got to be negative. And then if they add up to 3, do you know the positive one's got to be bigger than the negative one? And they got to be relatively close together. So at first this sounds impossible, but let's think about 504. 1 times 504, 2 times 252. Forget about it. That's never going to make a 3, right? Let's keep going. Does 3 go into 504? Yes, it does. The question would be how many times? 68 times? Okay, no, not 68 times. 168 times. Is that right? 340, yes it is. But still not going to give me a 3. If somebody sees the answer, you can send it out. 4 goes in there 126 times. Do you see as I go down, these numbers are getting closer to each other? Oh, sorry. Maybe I'll get lucky. Does 5 go into 504? No. Does 6 go into 504? Yes, it does. Does 2 and 3 both do? And that give me an 84. Still way too far apart. Someone found one? Okay, 21 and 24. Now you can do this one at a time till you find it, and it actually doesn't take you too long. You just keep trying numbers. And Isaiah is suggesting 21 and 24. And I multiply them and I get 400, 504. You are right. And this one is 3 bigger than the other one. So I think I'll put the 24 on the positive and the 21 on the negative. Now, this looks like a monster problem, but it took you about 30 seconds to find those numbers. Just keep going through the factors of 504. Now let's try it. 18a squared minus 21ab plus 24ab minus 28b squared. Common factor here is 3a, and that leaves behind 6a minus 7b. Now, by the way, once I have these numbers, I know I'm going to win. So I'm looking for 6a minus 7b over here. What do these have in common that would leave behind 6a minus 7b? 4b. That give me 24ab minus 28b squared. Now, do not say 4b, because if you do, I'm going to strike you for it. You know, it's going to cost you, because you are not multiplying here. You have to commit plus 4b or minus 4b. And by the signs, I want 4b times 6ab to be positive 24ab, so I want positive. Now I can finish. 6a minus 7b, 3a plus 4b. Could you have just guessed this with the factors of 18 and the factors of 28? Yes, you could. I mean, it's possible to guess it. But what I'm saying is if you try and guess it and you don't get anywhere in a minute or two, you can always use this method. This method always works. People call it the AC method. And I'm looking in your book. And he does tell you this, but he doesn't use that name. He calls it factoring by grouping again. But you see he's got the ax squared plus bx plus c. Okay, that's too small. Let's pull it up on our website. I already got the website ready. Okay, goodbye, Brian May. Goodbye, Wolfram Alpha. Maybe I should check if Wolfram Alpha could have done that. Here we are. We're in this section. We're in section 5.7 there. I want to look at section 5.5. I'm looking at page 372. So I want to show you the book does do the AC method. He just didn't call it that. First, he says do it by trial and error. And I'll tell you something. If you want to be fast and you practice the trial and error is faster. So most people who want to be quicker, they do it by trial and error, but you can do it by grouping right here. This is what we just called the AC method. Form the product of A and C. Find a pair of numbers whose product is AC and whose sum is plus B. Rewrite the middle term out of those two numbers, and then factor by grouping. Okay, so this is the same thing we said. He just calls it factor by grouping, which it is. When I learned it, it was called the AC method. Okay, good deal. But you could, let me go back to my paper. With practice, you could learn to go from there to there in one step. I had a folded piece of paper. With practice, you could learn to go from here to here in one step. I'll do an example for you. All I want to do is make sure you're covered. That if you don't see it, you got some way to do it. Let me show you how you could probably guess it out. And there's nothing wrong with guessing it out as long as you check afterwards that it works. Now, let me pick out another one here. Yeah, let's try this. 56, 5.5. Okay, so we got here. This looks kind of mellow, so I'm picking it out because it's deceptive. T minus 350 t squared. Okay, it's got a t, not an x, not a y, not an a, not a b. That's fine, it's just got a t. Notice the variables on the backside. Okay, no big deal. I'll put the variable on the backside. So that doesn't really stop me. What stops me at first is these huge numbers. And then I realize my checklist. If you're getting stuck on some weird numbers, always make sure you factored out the greatest common factor first before you try anything else. So I'm looking at these people and say, oh, this would be a lot easier on the eyes if I factored out that common factor. Has everybody got 100? No. Everybody got a 50? Yes. Can I do better than 50? I don't know. Let's pull out the 50 and find out. There's nothing wrong with doing a preliminary step. 50 times 4 is 200. This is 3 times bigger than 200, so I got 12t there. Now 50 go into 350 7 times. Got it. So the answer to this problem's got to have that 50. Don't give me an answer without the 50. Now, can I just concentrate on these puppies? I get a serious break, and that 7 can only be made one way, 1 times 7. I don't need to write the 1 there. I could just leave it as t. Now, talk about 4. There's not a lot of ways to make 4. Could be 2 times 2 or 4 times 1. Would 4 times 1 do it? Not likely, because that'll give me 28 t's and 1 t. That'll never be 12 t's. Maybe I was supposed to put the 1 there and the 4 there. But that doesn't look good either, because that's 4 t's and 7 t's. It could be 11, but it can't be 12. And do you see these different signs? One of these people is negative, so I need to differ by 12. No, 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 no. So I'm saying with a little bit of guessing and checking, let's try 2 and 2. Okay, I got 14 t's and 2 t's. Do you see that? That could be 12. But I want to have one of these people be negative, so I'm taking the difference of negative 12. I want the bigger piece to be the negative one. So how do I have to finish it? I had to put a plus sign there and a minus sign there. I did not use the AC method. I was guessing and checking. There's nothing wrong with that, as long as you check to make sure that you got the right answer at the end. These two make this, and times 50 makes that. Oh, sorry, up at the top. Times 50 makes that. Now, I wrote big, so I used a half a sheet of paper, but you can do this, and you can practice checking these until you get really good at it. If you use this method, guess and check, and guessing is not bad or wrong, as long as you check. Guessing is really bad if you don't check, right? But if you guess and you check whether you're right or not, you can still find the answer and correct yourself if you don't have the right answer. So there's nothing wrong with doing this. You can get very fast. If you practice this, this is the fastest way to do it. Sorry, by far the fastest way if you practice it. Okay, we gotta wrap it up, so we're going to close it out here. I got one more thing on my checklist, which I'll show you next time. What happens after you run all these dry? What happens after you remove the greatest common factor and you've grouped and you've broken down any trinomial you can? Is it over? And the answer is it is never over until you are certain you cannot go farther. There's one more thing you can do. Sometimes there's some special products. Maybe you've heard of them before. Difference of two squares, difference of two cubes, sum of two cubes. Sometimes there's some special things you can do to break a polynomial down if it doesn't fit in any of these categories. That's what I'll show you next time, along with section 5, 7, and 6.1. Okay, now remember your assignment, besides the written homework, besides the XYZ homework, your assignment right now is to go practice for the test, make a list of the problems that you are not certain about, that you want to see done. Bring me that list on next Tuesday, and then we'll practice together. You've already heard my speech. I didn't want these exams to be the most part of your work in this class, because this is too hard of a place to give people tests. I'm using these tests just to check what you can do and what you can show me. 20% of your grade, but you can't afford to throw out 20% of your grade. So you want to do the best job you can. Start practicing. Make me lists of questions you want to look at together. And that's what we'll do next week on Tuesday before the test. Okay, you guys have a good afternoon. Sun's out, although it's a little bit cool. And I'll see you again on Thursday.